instruction format, and their classification. As we already know that computer is a machine and it only works upon the instruction given by a human through input-output devices, let us try to understand instructions in computer's point of view. An instruction is a binary code that specifies a sequence of micro-operations for the computer. The instructions and data are stored in memory. The memory consists of cells. Each cell can store a bit 1 or 0. Each group of n bits is called word. Every computer has a unique instruction format code. The control unit of CPU or central processing unit initiates control signals to process each instruction code. The instruction format is specified in a rectangular box having bits of instructions. These bits of instruction are divided into groups called fields. The fields are an opcode or operation code 12 to 14. It specifies the operation for instruction. An address 0 to 11. It specifies the registers or the memory locations to be used for that operation. A mode 15. It specifies the way the operand or effective address is to be computed. There are other special fields which are used in certain conditions. For example, shift type instruction field describing number of shifts. Computer instructions having operations are executed on some data and are stored in memory or processor registers. The operands residing in memory or processor register are specified with memory address or register address respectively. The registers in a CPU are having 2 exponent k registers where k is number of bits. For example, CPU having 8 processor registers R0 to R7 will have address field of total 3 bits. R3 register having binary number 0, 1, 1. The instruction formats classified into different bases. Let us discuss them one by one. 1. Classification of instructions based on CPU organizations. Instructions are of several different lengths with varying number of addresses. The address field in the instruction format depends on the organization of internal registers. Most computer instructions fall into the following 3 types of CPU organizations: single accumulator instructions, general register instructions, stack instructions. Single accumulator type organization. In this organization, all operations are performed in the accumulator register. It uses one address field instruction format. For example, an arithmetic addition instruction and the corresponding operation of an assembly language instruction is add. That is, AC plus M into brackets X moves to AC, where AC is the accumulator register and M into brackets X symbolizes the memory word located at address X. All arithmetic, logic, load, and store instructions use the accumulator register, so these instructions have only one address field. General register type. General register types use either 2 or 3 address fields in their instruction format. Each address field may specify a CPU register or a memory word. For example, add R1, Y. This instruction means R1 plus M into brackets Y moves to R1. It contains 2 address fields, one for register 1 and the other for the memory address Y. Stack organization. Computers with stack organization generally have push and pop instructions which require an address field. For example, push Y. This instruction pushes the word at address Y to the top of the stack. Updating of the stack pointer is automatically done. Operation type instructions do not need an address field in stack organization. Moving to the next classification of instructions based on number of addresses, required. These are 3 address instructions, 2 address instructions, 1 address instruction. 0 address instructions. Let us discuss them one by one. Let us start with 3 address instructions. 3 address instruction formats can use each address field to specify either a processor register or a memory operand. The assembly language program to evaluate x, which is equal to a plus b times c plus d, is given below, together with the operations. Add r1, a, b. That is, m into brackets a plus m into brackets b moves to r1. Add r2, c, d. That is, m into brackets c plus m into brackets d moves to r2. Mul x, r1, r2. That is, r1 times r2 moves to m into brackets x, where r1 and r2 are 2 processor registers and m into brackets a denotes the operand at memory address specified by a. The 3 address format results in short programs when solving expressions. 2 address instructions. These instruction formats are most common in computers, in which each address field can specify either a processor register or a memory word. The 2 address code for the same expression is move r1 a, that is, m into brackets a moves to r1. Add r1 b, that is, r1 plus m into brackets b moves to r1. Move r2 c, that is, m into brackets c moves to r2. Add r2 d, that is, r2 plus m into brackets d moves to r2. Mul r2, that is, r1 times r2 moves to r1. Move x r1, that is, r1 moves to m into brackets x. The move instruction moves or transfers the operands to and from memory and processor registers. 1 address instructions. 1 address instructions use an implied accumulator or AC register for all data operations. Load A, that is, m into brackets a moves to AC. Add B, that is, a into brackets c plus m into brackets b moves to AC. Store T, that is, AC moves to m into brackets t. Load C, that is, m into brackets c moves to AC. Add D, that is, AC plus m into brackets d moves to AC. Mul T, that is, AC times m into brackets t moves to AC. Store X, that is, AC moves to m into brackets x. All operations are done between the AC register and a memory operand. T is the address of a temporary memory location required for storing the intermediate results. 0 address instructions. Stack is included in the CPU for performing arithmetic and logic instructions with no addresses. The operands are pushed onto the stack from memory, and ALU operations are implicitly performed on the top elements of the stack. The address of the next instruction is held in a CPU register called program counter. A stack organized computer does not use an address field for the instructions add and mul. The expression x equals a plus b times c plus d will be written for a stack organized computer as given below. Push A, that is, A moves to toss. Push B, that is, B moves to toss. Add, that is, A plus B moves to toss. Push C, that is, C moves to toss. Push D, that is, D moves to toss. Add, that is, C plus D moves to toss. Mul, that is, C plus D times A plus B moves to toss. Pap X, that is, toss moves to M into brackets X. where toss is the top of the stack. To evaluate arithmetic expressions in a stack computer, it is necessary to convert the expression into reverse Polish notation. The term zero address is given because of the absence of an address field in the computational instructions. Well, next classification of instructions is based on type of data they can access or the type of data they can refer to. Memory reference instructions: 0 to 1 address, 12 to 14 opcode from 000 to 110, 15 that is I. If I equals 0, then direct addressing, else indirect addressing. Register reference instructions: 0 to 11 makes up register operation, 12 to 14 makes up opcode 111, 15 is to 0. Input-output instructions: 0 to 11 makes up input-output operation, 12 to 14 makes up opcode 111, 15 is to 1. Thank you and see you in our next section.